Good day, everyone. I am Divine Panerio together with Daryl James Remotigue. Our topic to be discussed today is about improving a classroom-based assessment test. But before we will start, let's first have the objectives. First, identify terms related to improving classroom-based assessment tests. Second, analyze basic concepts, procedures, and techniques in the different ways for judgmental item improvement and empirical-based procedures. In this chapter, we assume that you already know how to plan a classroom test by specifying the purpose of constructing it, the instructional outcomes to be assessed, and preparing a test blueprint, and also the techniques and strategies for selecting and constructing different items format to match the intended instructional outcomes. Because these things are necessary in this chapter to provide practical and necessary ways for improving teacher-developed assessment tools. In 2011, Pufan suggests two approaches to undertake item improvement. First, the judgmental approach, and second, the empirical approach. So first is the judgmental item improvement. It is a method of enhancing or reviewing test questions by using human judgment to identify potential flaws and suggest revisions. There are three judges here: the teachers itself, who know exactly what are the tests for, the outcome to be assessed, and the item's level of difficulty. Second is the teacher's peers or colleagues. They are the one who are familiar with the curriculum standards. And the last is the students itself, who can perceive difficulties based on their past experiences. So first, we have the teacher's own review. As they are the one who knew exactly what are the tests for, it is advisable for them to take a second look at the assessment tool he had advised for a specific purpose. Because if they presume perfection right away after the construction, it may lead to failure to detect shortcoming of the test. That's why Pufam give 5 suggestions for teachers to follow in exercising judgment. So number 1 is the adherence to item-specific guidelines and general item writing commandments. Here, the teacher should follow the specific guidelines measuring the lower level and the higher level thinking skills, because these guidelines will help them to check how good the item has been planned and written, particularly in the alignment to intended structural outcome. So second is the contribution to score-based inference. So the teacher examines if the expected scores generated by the test can contribute to making valid inference about the learners. So it's all about understanding how much each piece of information matters when using scores to make decisions. The third one is the accuracy of the content. It is the information being presented is correct and free from errors. It's about making sure the facts, the details, and the descriptions are all true and verifiable. But if and only if changes may occur due to new discoveries and developments that can redefine the test, when this happens, the items or the key correction may have to be revisited. Number 4 is the absence of content gaps. This review criterion is especially useful in strengthening the score-based inference capability of the test. But if the current tool misses out on important content now prescribed by new curriculum standard, the score will likely not give an accurate description of what is expected to be assessed. That's why I noted here that there should no important topics or information missing from something. Teacher must ensure that assessment tools matches what is currently required to be learned. It is a way to check the validity of the test. And last is fairness. The discussions on item writing guidelines always give a warning on unintentionally favoring the uninformed students obtain higher scores. That's why the teacher should give rid of faulty and biased items and writing clear instructions to give everyone an equal chance and not being biased towards any person or particular group, and also to add to the fairness of the test, because sometimes biases cannot be avoided. So let's move on to the second judges to assess the quality and effectiveness of assessment items, which is the teacher's peer or colleagues review. This involves teachers, peers, or colleagues evaluating each other's assessments to identify areas of enhancements because they are the one who are familiar with the standard curriculum. The teachers can consult or they can ask opinions to their colleagues to enhance their assessment items. But although this activity is time consuming, but it is guaranteed that you always yielded good results for improving tests and performance tasks based on assessment tasks. These are the suggestions that given by the test experts as basis to review checklists. First, do the items follow the specific general guidelines in writing items specifically on being aligned to structural objectives, making the problem clear and ambiguous, providing plausible options, avoiding unintentional clues, having only one correct answer. B. Are the items free from inaccurate content? C. Are the items free from obsolete content? D. Are the test instruction clearly written for students to follow? E. Is the level of difficulty of the test appropriate of level of learners? And last, is the test fair to all kinds of students? Moving on to the last judge to assess the quality and effectiveness of the assessment items, which is the student review. The judgment here is based on students' experience in taking the test and their impression and reaction during the testing event. The process can efficiently be carried out through the review of questionnaire. So these are the example of the item improvement questionnaires for students. Number 1, if any of the items seem confusing, which ones were they? Number 2, did any items have more than one correct answer? If so, which ones? Did any items have no correct answer? If so, which ones? Number 4, were there words in any items that confuse you? If so, which ones? And last, were the directions for the test or for the particular subsections unclear? If so, which ones? These are the examples of the questionnaires that helps the teachers to identify areas where items might be confusing, unclear, or not properly worded to the students. By incorporating students' feedback, teachers can improve the clarity, the fairness, and the effectiveness of the assessment.
Good day everyone. Since we had already discussed the first approach, now we are in the next approach, which is empirically based procedure. In test development, this procedure is known as item analysis. Item analysis means that we look at the data of each test item separately to see how well it works. A test item is considered good if it meets certain standards. So these standards are measured through two important indicators. First is the difficulty index and the discrimination index. So what is difficulty index? Difficulty index tells us how easy or hard an item is for the student, while the discrimination index shows how well the item can separate the high-performing student from low-performing student. By analyzing these two factors, test developers can make sure that the test items are reliable and useful in measuring what they are supposed to measure. Now let's move on to norm reference tests. So in norm reference tests, the difficulty index and discrimination index are closely related. The difficulty of an item affects how well it can discriminate between students with high and low performance. But in the context of criterion reference testing, which focuses on mastery, the interpretation is little different. An item with high difficulty index does not automatically mean it is weak or bad item. Instead, it shows the capability of the learner to reach the expected outcome. When students are able to answer difficult items correctly, it becomes strong evidence that they have truly mastered the lesson or being tested. So in empirically based procedure, there are 4 index. So first is the difficulty index, second is the discrimination index, third is the distractor index, and last is the sensitivity to instructional index. So the difficulty index is used to measure how easy or hard a test item is. So it is written as P is equals to R divided by T, where P stands for the difficulty index, R is the total number of students who answered the item correctly, and T is the total number of students who tried the item. The closer value of P is to 1, the easier the item is, because many students got it right. On the other hand, if the value of P is closer to 0, the item is harder since only a few students answered it correctly. This helps the test developer see whether a question is too easy, too hard, or just right. Let us look at the example of the difficulty index. For item 1, there were 45 students who answered and 30 got it right. So the formula gives us P is equals to 30 over 45 equals to 0.67. This means that 67% of the class answered it correctly, while 33% missed it. For item 2, out of the same 45 students, only 10 answered correctly. So P is equal to 10 over 45 equals to 0.22, which means only 22% got it right, while 78% missed it. In informative reference tests, we can see that item 2 is more difficult since less than 1/4 of the class was able to answer it correctly. On the other hand, in criterion reference test, the results show that the class did not much better on item 1 than item 2. This also tells us that many students still have a long way to go in mastering the skill or lesson being measured by item 2. Now let's move on to discrimination index. This tells us how well a test item can separate students from who are more knowledgeable from those who are less knowledgeable. In other words, it shows if the item can really tell the difference between students who understand the lesson well and those who do not. For classroom tests, the discrimination index helps us see if high-performing students are more likely to answer an item correctly compared to performing students. Let's say, for example, imagine we divide the class into 2 groups. The top 10 students with the highest score and the bottom 10 students with the lowest score. If 9 out of 10 students in the top group get the item right, but only 2 of 10 students in the bottom group answered correctly, then the item has a good discrimination index. This means the item can clearly separate the stronger student from the weaker student. When we talk about discrimination of the result, there are three possible outcomes. First, we have a positively discriminating item. This means that more students from the high-scoring group answer the item correctly compared to the low-scoring group. This is what we want to see because it shows the item can separate stronger learners from weaker ones. Second, we have negatively discriminating item. This happens when more students from low-scoring group get the item right compared to the high-scoring group. This is not good sign because it shows the item may be confusing or misleading for better student. Lastly, or a third one is we have a non-discriminating item. This means that the proportion of students who got the item correct is about the same for both high-scoring and low-scoring group. In this case, the item does not really help in telling apart the stronger learners from the weaker ones. Discrimination index or D can be calculated using different formulas. The most common one is D is equals to R sub U over T sub U minus R sub L over to T sub L, where RU is the number of students in the upper group who got the item correct, and T sub U is the total number of students in the upper group. R sub L is the number of students in the lower group who got the item correct, and T sub L is the total number of students in the lower group. Another way to write the formula is D is equals to parenthesis R sub U minus R sub L over T, where T is the number of students in either group. We can also express it D is equal to P sub U minus P sub L, where P sub U is the proportion of correct answer in the upper group, and P sub L is a proportion of correct answer in the lower group. For example, let's say we divide the class into two groups, 15 students in the upper group and 15 in the lower group. If 12 students in the upper group answered correctly, then P sub U equals to 12 over 15, is equals to 0.80 or 80%. In the lower group, if only 6 students answered correctly, then P sub L is equals to 6 over 15 equals to 0.40 or 40%. Using the formula D is equals to P sub U minus P sub L, we get D is equals to 0.80 minus 0.40 is equal to 0.40 or 40%. This shows that the item has a positive discrimination index, meaning it works well in distinguishing strong students from weak ones. To get the proportion of the upper and lower groups, we need to follow a few steps. First, we score all the test paper using the answer case so that we can get a total score of each student. Let's say for example, if the test has a 40 question, the maximum score is 40. Second, we arrange the score from highest to lowest. Third, we divide the class into two groups. The high group, which includes the top scorer, and the low group, which includes the bottom scorer. After that, we calculate the P value for each group. This is done by dividing the number of students in the group who got the item correct by the total number of students in that group. Finally, we get the discrimination index by subtracting the p-value of the lower group from the p-value of the upper group. Let's say for example, we have 20 students. The top 10 students will form the upper group, and the bottom 10 will form the lower group. If 9 students in the upper group answered an item correctly, the p-value is 9 over 10 is equals to 0.90 or 90%. If 5 students in the lower group answered the same item correctly, the p-value is 5 over 10 is equal to 0.50 or 50%. Subtracting them, we get 0.90 minus 0.50 is equal to 0.40. This result means that the item has a good discrimination because it clearly separates high scores from low scores. When we evaluate these items, we also need to look at items with negative discrimination indices. Even if the value is high, a negative index is a sign that the item needs immediate revision or even deletion. In multiple choice tests, a negative discrimination index often shows there are errors in how the item was written. For example, it may happen because of the wrong K, where the supposed correct answer is actually a distractor. The real correct answer was not marked as the K. Another reason could be an unclear stem, which makes the question confusing and allow more than one possible correct answer. It can also be caused by ambiguous distractor, where the choices are tricky and divide even more knowledgeable students. Lastly, if it may happen if the K option is implausible, meaning that strong students will not choose it because it does not make sense. Let's say for example, a student in math undergo a math test. The K answer is option A equals to 12. But the real correct solution is option C, which is 15. Then good student will choose 15, while weaker student may just guess 12. The result in a negative discrimination index because the high score got it wrong while the low scores got it right. That's why item with negative D must be carefully checked and revised. That is how we evaluate item tests.
So let's move on to another empirical procedure to discover areas for IT improvement that utilizes an analysis of the distribution of responses, which is the distractor analysis. The distractor analysis, it is a method to evaluate the effectiveness of incorrect answers options in multiple choices test. So the distractor analysis, it can detect differences in how the more able students respond to the distractors in a multiple choice item compared to how the less able ones do it. And it can also provide an index of the plausibility of the alternatives, that is, if they are functioning as good distractors. So here is an example. So the teacher prepares a multiple choice test for students on the topic of the Philippine national heroes. So the question is, who is considered the father of the Philippine Revolution? So in the option A, Emilio Aguinaldo, B, Andres Bonifacio, C, Jose Rizal, and D, Apolinario Mabini. In the option A, 50% of the class choose the option A, and 60% of the class choose the option B, and 20% of the class choose the option C, and lastly 5% of the class choose the option D. And the correct answer is the option B, which is majority of the class choose the correct answer. So here we see that the distractor is the option A, C, and D. So in option A, 50% of the student choose this option, which means this distractor works reasonably well. And also the option C, which is 20% of the student choose This distractor also a good distractor. And lastly, the option D, there are only 5% of the students choose this option. So this distractor was not a good distractor. So we have another example here, which is the distractor analysis table. So let us also answer the following questions based on this table. First, what kind of items do you see based on their D or the discrimination indices? So here we have a negative discrimination indices. So this indicates that the more lower group students than the upper group student choose the correct answer or the distractor. Number two, what does the respective D indicates? So the D here, which is this indicates the D here, the distractor index indicates how well an item differentiate how will the item differentiate between the high and the low performing students. And here we have a negative D. So it suggests that the item is negatively discriminating. So it means that more students from the lower group answered the item correctly. The number three, which of the two items is more discriminating and why? So in this table, the more discriminating item is the item number two because its discrimination index is negative 0.50, which is more negatively discriminating than the item number one that has only negative 0.35. It is note here that the farther the D value from 0, the more discriminating the item is. So why it becomes more discriminating item than the item number 1. Then number 4, which item need to be revised? So in this situation, both items need to be revised because they have both negatively discrimination indices. So this indicates that the items are not effectively differentiating between the high and the low performing students, suggesting flaws in the item design or the distractors. Now let's move on to the last empirical procedure, which is the sensitivity to instructional index. So sensitivity to instructional index, or SI, is referred to as sensitivity to instruction index, and it signifies a change in students' performance as a result of instruction. So in the context of item performance, the SI will indicate if the proportion value is obtained for the item in post-test is greater than the p-value of the pre-test. So it means that it shows whether students perform better on a specific question after the instruction compared to before instruction. So we have the calculation here. So sensitivity to instruction equals the post-test minus the pre-test. So we have the example here. Consider an item where in a class of 40, 80% answered it correctly in the post-test, while 10% did it in the pre-test. Its proportional value for the post-test is 0.80, while the for pre-test is 0.10. So its sensitivity to instruction is 0.70. So this indicates that the proportion of improvement in students' understanding from pre-test to post-test. So that's all. Thank you for listening. I hope you learned something from our topic.